This conference will now be recorded.
Hello, everyone. This is Brian Gockel, Weather Service Office of Observations, welcoming you to the weekly, today's instance of the weekly Satellite Book Club Seminar Series. We've got a great talk lined up with you today on the use of satellite imagery to capture dust plumes. Sharon Sullivan with us here from WFO Albuquerque, and facilitator, thanks Brian, Curran is going to be our facilitator today, helping us out, keep the session moving in with Q&A. As you heard the prompt a moment ago, the session's being recorded as usual. We want folks who can't make it today to be able to listen in and benefit from this later on, or those of us who need a refresh. As usual, we'll do the Q&A right after the presentation, and attendees are encouraged to post your questions in the chat room, in the chat area, and they will be fielded and gone through from there. We'll try to get to everyone's questions. We usually do. And this is a shout out for any future presenters. We have a broad range of satellite topics that has been briefed at the Satellite Book Club. But there are always new and interesting applications. We would welcome your topic. And so thanks to the training team for creating materials that they can help create materials that might be unavailable. And Brian Mata is the focal point for that. Thanks to the TARS team for putting this on. Kashad Bowman is our primary organizer and facilitator for this, gets us all ready. We appreciate the input from the Chief Learning Officer's Office. Our partnership is always with the GOES-R program and JPSS program, who have provided various sponsorship and support, as well as hard work on these products and capabilities that are demonstrated. So Sharon Sullivan's our speaker today, and she's been a meteorologist at the Weather Service for about 3.5 years officially. Started off in Juneau, Alaska, and at the Albuquerque, New Mexico office for 2.5 years. As a native New Mexican, she's been interested in meteorology since having been about 8 years old and saw a funnel cloud during recess. She attended the University of New Mexico, where she earned her BS in Applied Mathematics in 2014, while also volunteering at the Weather Service Albuquerque office. She then went on to continue her education, earning a Master of Science from University of Wyoming in 2016, where she was on the Plains Elevated Convection at Night, PECAN field campaign. Her professional interests lie in decision support applications and social media, severe weather, and outreach to underrepresented youth in the Hispanic community. Her personal focus includes areas of ballet, travel, trying new foods, and the outdoors, fishing and hunting, for example. Hey, Sharon, thanks so much for coming to brief us today, and welcome to the Satellite Book Club.
Thank you, Brian, and of course, thank you to Kashad and Lee for organizing everything. So I guess we'll go ahead and get started here. So good morning. As you all know, my name is Sharon Sullivan. I'm a meteorologist here at the Albuquerque office, and today I'll be talking about satellite imagery to capture dust plumes. So the National Weather Service Office, both in El Paso and in Albuquerque, have done various studies on the climatology of dust storms, of which El Paso is usually affected by about 15 dust storm events every year. They found that can be separated into different categories, from the synoptic events, Pacific cold fronts moving west to east, and backdoor cold fronts moving in from the east. And also our mesoscale events occurring during the summer months are thunderstorms, dry microburst, and haboobs. We can also have some surface cyclogenesis over northeastern New Mexico that helps tighten the surface pressure gradient and taps into many dust source regions during the peak mixing of the day. And if our frontal passage is close to maximum heating, this is when it's most effective to produce reductions in visibility when our strong surface winds lie over the playas and our dust source regions. But our strong winds alone aren't sufficient for significant dust events to occur, but the wind must be sufficiently turbulent to loft dust, and it must be occurring in a reasonably unstable environment. There's also been some studies that have been done linking above normal dust event days to below normal rainfall. And even 1 year after El Nino events, there's been some increases in the dust storm events occurring the next year. So some background on this topic. So it was Saturday, March 13th, and we were sitting there in operations. We saw the dust plume coming from Mexico through New Mexico. We anticipated the drop in visibility, and that increased our confidence to be proactive and put some messages out on social media. And it was actually the next day that the National Weather Service office in Boulder/Denver had answered back our tweet saying that there were reports that dust had been found as far north as Loveland and Fort Collins, Colorado. So our synoptic setup for this event, again, Saturday, March 13th, we had strong, deep, slow, low pressure tracking into the Four Corners region that morning, dragging a Pacific cold front with it. And it slid across the New Mexico-Colorado border through the afternoon and evening hours, bringing a lot of deep, southerly persistent flow through the state. And for our forecast area, we cover much of the northern 2/3 of New Mexico. So the western half of the state here, draped with the Pacific front, had winter weather advisories and a high wind watch. And across the east, we had a dry line for across the New Mexico-Texas border. So we had a tornado watch across our far eastern counties, some red flag warnings. But this is not entirely unusual for our forecast area, but it does provide a unique challenge for these multiple hazards that do occur. And we can use satellite imagery, including RGBs, which I'll talk about here in a little bit, to triage these hazards that we're faced with and these evolving weather threats. So going along with kind of the dust climatology that our office and then El Paso had studied. So this was kind of a typical surface pattern where the blowing dust occurs ahead of the front in the warmer air. And we can see based on our 500 millibar heights, with our lines of constant geopotential heights aligned parallel to the geostrophic flow, the low becomes enhanced by positive vorticity advection to further strengthen and deepen the low, increasing the pressure gradient and causing these stronger winds to occur at the surface. So this case in particular, the dust actually originated from agricultural portion in central Mexico with these distinct orange, reddish brown soils. And much of northern and central Mexico currently is experiencing severe to extreme and even exceptional drought conditions. So we have these strong winds traveling 60 to 70 miles an hour, blowing ahead of the storm, scooping up a massive amount of dust from Mexico's extremely dry landscape and intertwining it with the winter storm across the western US. Moreover, drought-like conditions can result in looser soil, making it easier for it to blow away. So in addition to reducing visibilities and creating a brown sky. Dust events can also be detected through satellite imagery. And we actually had a repeat event here the following Tuesday, March 16th. It was just another storm in a series of storm systems. This time we had wind advisories, high wind warnings, and winter weather advisories again. Our low is moving southeast into southern Nevada with a Pacific front reaching the New Mexico border with brisk westerly winds that morning of March 16th. We also had a lee side low over northeast New Mexico, in addition to 50 to 60 knot 700 millibar jet aloft, which essentially increased the wind speeds over the southern areas of our forecast zone. So we can see here from some of the events of the day, our satellite imagery, our east geocolor, our different dust source regions, white sands in southern New Mexico, and then also our dust, again, being lofted from Mexico. And some of the impacts that we had, there was visibility that was reported less than a mile. And we also had our Roswell relief route that was closed to strong winds and blowing dust. So our satellite imagery helped us to anticipate these impacts and help get the word out on social media. Of course, just because satellites can detect dust in the atmosphere doesn't always mean that scientists can see it in satellite imagery. So why is that? If you're wondering how a satellite traveling 500 plus miles above the Earth's surface can detect something even as small as dust in the first place, it's because dust, like other aerosols, absorb and reflect light. So different satellite sensors aboard the GOES IM Imager, 13 and 15 satellites, advanced very high resolution radiometer, AVHRR, that's aboard the NOAA satellite series, and then VIIRS, the Visible Infrared Imager Radiometer Suite, aboard NPP, so that's the National Polar Orbiting Partnership. These sensors can detect areas of reflection and absorption and indicate varying amounts of the aerosol in the atmosphere. So we can see on the top right here, in our visible satellite imagery from GOES East, it can be hard to distinguish our dust clouds from the background. But taking another approach, scientists at the Cooperative Institute for Research in the Atmosphere at Colorado State have developed an algorithm known as DEBRA. And DEBRA is the Dynamic Enhanced Background Reduction Algorithm. As its name implies, DEBRA works by reducing the background in an image, whether that be polar orbiting or geostationary satellites, to grayscale, thereby enhancing the appearance of the dust clouds, which appear yellow in this imagery. And the intensity of the yellow corresponds to the confidence that a given pixel contains dust. But taking yet another approach, scientists at the European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, have developed a method for processing satellite imagery specifically designed to aid in the detection of dust. So as we can see at the bottom right, there's our mesosector showing our Dust RGB. This imagery is named both day and night and combines 3 of the satellite's imagers in the red, green, and blue channels so that dust clouds can appear pink or red, depending on the time of the day that the image was produced. So how does this work? So the Dust RGB uses several infrared-based channels, differentiating various cloud characteristics in dust. So it takes the difference between channels 15 and 13, essentially a 12.3 to 10.4 micron difference. That takes advantage of low absorption by dust in channel 15 resulting in a large positive difference, which makes it a little bit different from like the air mass and the day cloud RGB imageries. So this includes the red component of dust RGBs and causes the dust to have a greater amount of red compared to other cloud features. And our magenta color in the RGB results because the dust is relatively warm compared to the surrounding area. And the blue component in the RGB is the 10.4 micron channel, which is sensitive to the thermal properties of the object. So this shading with the pink and the magenta gives us the higher confidence that these given pixels do contain dust within the RGB imagery. So Albuquerque forecasters have used the dust RGB imagery in the past during some high wind events across the data void regions of New Mexico that are relatively cloud-free, and helps our forecasters understand where dust may likely be occurring under these adjacent cloud features, which helps us to track the dust development and distribution over time. So this gives the added value for the dust RGB, so our users can analyze the dust plumes when some single channel imagery may not be able to detect dust features, maybe such as the visible channels. Even on our bottom left here, we have our natural color RGB, and it may often miss dust because the underlying surface has the similar color to the dust itself. So our evolution of this event here, I know on the top left we're using the nighttime microphysics, even though sunlight may negate some of the interpretation of this, but just trying to show that even you can detect dust in the pink here being drawn up from Mexico into central and northern New Mexico, and possibly into Colorado in this interpretation. And even by 7, 8 o'clock, you can still see the dust plume going strong with this pink plume that you can see going up into Colorado at this point. And then finally by 9 o'clock, you can see some of the dust plumes starting to diminish, although you can still see some transport up through southern New Mexico and then into northern Colorado. So AWIP's one of the tools that we use here in operations. If you're not familiar with it, you can find some of the RGB composites through the Goes East and West menus. I'm just going down and finding the RGB composites. There's also a few links on the right where you may be able to find some RGB satellite imagery, including some archived image. So we're going to shift gears a little bit. And in some studies that have been done by Dr. Thomas Painter and Dr. Stefan Rahimi-Asfariani, the snow darkening effects due to deposition of light absorbing particles, including dust, on surface snow has been said to increase surface snowmelt by up to about ½ inch during the late spring and early summer months, effectively increasing runoff prior to June due to the surface absorptivity and anomalous warming. But even across regions further away from these dust emission zones, namely the northern Rocky Mountains, the dust particles tend to be smaller and more scattering. But rising temperatures have already led to earlier melting of the snowpack across the western United States, in which agriculture in these areas depends so heavily upon these water resources and the timed release of seasonal snowmelt. So reducing these soil disturbances in the desert Southwest and studying this problem in a high resolution framework and these interactions is of great interest at this point. So in conclusion, dust can be hard to see in the visible and IR imagery because it is optically thin and because it appears similar to other cloud types such as cirrus. The RGB product is able to contrast the airborne dust from lower level clouds using the channel differencing and the IR imagery. And this differencing allows dust storms to be observed both day and night, appearing pink and magenta during the day and can vary at night depending on the height of the plume. It can be distinguishable from the hot land surfaces such as deserts and then from cooler oceans, allowing forecasters to track dust storms even across oceans. For some of our cloudy regions, the RGB allows users to infer the relative temperature of the observed cloud top surface as a proxy, as well as cloud phase and thickness. So it's just some of our primary applications. One, obviously identifying dust, easily distinguishable from the surrounding clouds, both day and nighttime in the lower levels. We can infer the height of dust, but at night only, based on the color changes. So at night, it appears more of a purple plum color and changes to pink and magenta with its height. And then some of the secondary applications, the cloud height and type analysis. We can infer air mass and moisture boundaries, low versus high humidity. And we can even see volcanic ash, which appears as an orange or a peachy color. But it does have its own limitations, as high clouds can obscure dust, making the plumes beneath them difficult to see, as well as the spatial analysis. And then while we know the height, the thickness is typically unknown. So these magenta pink variations during the daytime are not necessarily indicators of thickness, but very thick plumes may sometimes appear purple in daytime scenarios. And over the oceans, dust tends to appear similar to marine stratus, like a light purple color, particularly at night. And we can have some gaps in coverage with our combined use of the MODIS and VIIRS. We have approximately 4 Dust RGB imagery products, so a total of 8 per 24 hours. However, some of the overpass times can vary by roughly an hour or so on either side of the center point. So there can be some gaps in LEO coverage between about 3 to 9 a.m. Mountain time, about 3 to 7 p.m. Mountain time as well, during which forecasters may not have access to Dust RGB products. And in AWIPS, it can be slow to load and sometimes bog down the system. But in comparison to other products, it does relatively well, able to distinguish that contrast between the dust and the background. Unlike IR imagery, where dust becomes more difficult to detect at night or over the oceans. And so some of our operational impacts, we can use the Dust RGB product to improve our decision support services for our issuance and verification of different products, including some like air quality, which the impacts of dust may aggravate some respiratory illness symptoms, including those of COVID-19. And we can also use it for communicating with state officials, able to forewarn the public or driving so they can put up roadway message signs. And we can also help us determine the timing, onset, duration, and termination of dust events for aircraft that would otherwise have to seek alternative landing or carry extra fuel. And with that, I'd like to thank the NWS Albuquerque staff, especially Brian Geyer for their assistance on this project, some of the other studies that have been done, and then Dr. Rahimi, and then Jordan Rabinowitz for some of their satellite guides. And with that, I will take any questions.
Thank you, Sharon. This is Brian Curran. We do have some questions right now. Let's go through those. Bill Schoberg, I hope I'm pronouncing your last name correctly, asks, what actions does the local populace take during these dust storms to minimize the impacts?
That's a good question. It depends on whether you're driving or whether you're in your home. As far as for driving, it's best to pull completely off the road, turning your lights off. Otherwise, other cars may be able to follow you and think that's the roadway over there. So just by having these products and messaging signs up, that helps mitigate some of the impacts. And then as far as if like other respiratory, circulatory illnesses, it's best to stay inside if you know you are going to be impacted by these events. Face coverings, that may also help.
A related question we have from Bill Line is, what role does satellite imagery play in your issuance of dust storm and blowing dust warnings in providing dust-related DSS?
So it kind of gives us more confidence when we're issuing these products. If we can look at some of the sites downstream and see that those are producing visibility restrictions, and we know those impacts are going to continue further upstream, that kind of gives us the confidence that we need to issue products, be proactive with DSS and messaging, talking to our partners.
Okay. Tim Schmidt asks, did you get a chance to look at level 2 or derived GO16 products such as aerosol detection or optical depth?
No, I hadn't taken a look too closely at those, kind of focusing on the RGBs and some of their differences, but I think that may be a great suggestion to go back and look at those and how those were affected throughout the March 13th and the March 16th event.
Okay. Curtis Seaman has a comment. He says that Sarah is now making Deborah available on their LDM server. Would you have interest in receiving this product? And I also see that Bill Line has a comment that's related that NWS Southern Region has recently begun to ingest Deborah dust over the Southern High Plains and should be available to West Texas, New Mexico offices in the near future. Albuquerque will be able to install and view in AWIPs. So that's some good news for us.
Yeah, that's
that are
great.
affected by these.
Yeah, definitely the more products that we can have to kind of help make those decisions would be helpful.
Cool. Well, I've got everyone's attention. Want to highlight that a week from today, on Thursday, May 6th at 12 p.m. Eastern Daylight Time, Margaret Curtis, a meteorologist from the Portland, Maine WFO, will discuss satellite data in the AWIPS graphical forecast editor. So that's going to be pretty cool. Also, if you have any attendees here that wish to contact the SBC folks, Lee Byerly and Gashad Bowman, on use or configuration of satellite products, and actually I need to get with Lee offline because of an issue we're having here. For questions about the SBC or configuration of satellite products, and more information will follow in an email from the Tower S team. So with that, I'll get back to some questions real quick as we have time. And I'm looking through them now. This is a question from Brian Gockel. Have you had cases where there's been a combination of wet and dry convection complicating the dust signatures, such as wetting snow or raining out dust? And if you can, you say anything about how you resolve either analysis or forecast the dust in the precip areas?
Yeah, so that does present some complications. Of course, like the climatology from the studies doesn't always fit those categories. Like we say, more of the kind of the drier events may occur during like those late winter to spring months, and then like the summer ones associated with like monsoons and like the haboobs. But we can also get dry microburst, wet microburst combinations during the summer that kind of may complicate that scenario a little bit.
Okay, I have a quick comment. I've noticed that the source regions of dust that affect the Midland area mainly are from the Pleistocene area lake beds of the, I guess it's the Lagunas Palomas there in northern Chihuahua.
Yes.
And we don't have much in the way of stuff coming from white sands, but we do have brown dirt coming in from the cotton fields sometimes in the southern plain or southern high plains region of the Panhandle to our north. So that's always kind of interesting. We can tell when the winds change by the quality of the dirt, or as I say, V. Del dirt. Ross Van Til asked the question: do you think the GeoColor should be made operational NWS required product, e.g., available on AWebs?
Well, I can't speak for everyone, but I think it's a great addition to have. It's a great resource, and I don't think it may be utilized enough, especially over the past few years. I think our office has been one to kind of test out the RGB in the early stages and see kind of the impacts and applications of this. So I think it's a great addition to have, just kind of on the regional impacts, and then you can even.
Cool. Okay, Bill Line has a question again. Do you view VIIRS imagery during blowing dust events, and would it be helpful to have dust imagery from VIIRS in AWebs?
I don't think we utilize that one as much. I think we're kind of focused mainly on some of the RGBs. But again, I think that would be another great addition to have. Like the more tools that we can have, I guess the more confidence in some of these decisions that we're making.
Cool. Scott has a question. Does the Dust RGB or Deborah product have any real information about surface visibility? Is the dust ever mostly above the boundary layer, or is there usually enough vertical mixing so that a satellite signal means a surface visibility obstruction is occurring?
Yeah, I mean, you can't infer all that from satellite. You need some observations as well. And then, of course, spotters are useful, and then social media pictures. But as I kind of mentioned during kind of the closing remarks, you can't always tell the thickness of dust. I mean, using the RGBs, but you may be able to infer some of the heights based off of those changes from like the pink to magenta color to more of like the purple plum color at night. So it does help, but I think you still need some additional observations to go with it.
Yeah, and then we had a case here in Midland in late March, I believe, where a haboob developed from a storm over northern Lee County, New Mexico, and raced south and east toward a fire that we had in Andrews County, Texas. So having that information, the dust information in Deborah, was very crucial for us to provide IDSS for the fire folks who were fighting that fire. And of course, wind shifts usually kill the most firefighters. So, having that kind of information obviously is very useful to have. Going through here, and sorry, Mike, I'm going to probably butcher your last name, Pavlonis. Given human and IT bandwidth limitations, how many different types of satellite images are really needed to observe the same phenomena? In this case, how many different types of satellite images do you need to adequately observe dust?
Well, I mean, just alone, the Dust RGB does a pretty good job, but you may have maybe just like one or two other sources that you can kind of look at as well. But yeah, like Mike said, I had mentioned that it can be kind of slow to load and bog down the system. So just I guess having enough images to get the information that you need, and then maybe an additional source.
Okay. Julie Phillipson, my coworker from Midland, has a comment that she says that we found Deborah to be very useful in West Texas, as it can help to easily visualize even the faint lofted dust during the onset of a blowing dust event. We've shared screen grabs of static images and animated GIFs of Deborah output GIFs or GIFs. We'll have that argument later, of Deborah output on our social media channels, and it's been very well received by the public and our partners. Have you had the same experience there in Albuquerque?
I don't think we've used Deborah as much as, I guess, the Dust RGB product. I have seen some of the other surrounding offices use it, and it seems like they've gotten a pretty good reception from it, and that some of the users, they seem to like it and were able to interpret it relatively easy.
Sure. Joshua Schrader, I believe, comments. He says, "Great talk," and I would certainly concur with that. It's been a great talk that you've given us, Sharon. I'm looking through, and I don't really see any additional comments or questions. Bill Line does have a comment that he says that Deborah dust is much easier to interpret than an RGB.
Right.
Making it more ideal for social media, because you do see that color difference. Those I don't know, it's a yellowish orange color that highlights the dust in Deborah, that makes it easier to pick out than other RGBs. Anyone else have any questions before we wrap this up? Okay. Hearing none, I guess I'll pass things back over to Brian, Gockel, and Lee Byerly or Kashad Bowman, if they have any other questions or comments.
Okay, Brian Curran, thank you. This is Brian Gockel. Last call for any questions or comments. While you're thinking about that, if any, Brian, thank you very much for facilitating. I may have neglected to mention at the beginning, Brian's the Sue from WFO Midland. So Sharon and Brian are neighbors. So what a great pair to facilitate this. I guess they give each other, they pass dust storms back and forth, but Sharon, great presentation. Thanks for your demonstration of the use of satellite products, the RGBs, the Deborah tool, Imagery, and so forth. And thanks also to the participants, your questions, really very much appreciated. And as mentioned earlier, as we wrap up, just a friendly reminder that we've got another Satellite Book Club session a week from today, where Margaret Curtis from WFO Gray, Maine, I think that is going to talk to us about satellite data in the GFE. So look forward to seeing you then and hearing from you then. Until then, have a great week. Thanks, everyone.
Thank you all for your great questions. And thanks again, Sharon, for your great talk.
Thank you.